All right, so we're going to move on to lesson 6.4. Present my screen and we'll start. Okay, so we're going to be talking about mid segments of a triangle. Okay, the mid segment of a triangle is a segment that connects the midpoints of two sides of the triangle. Every triangle has three mid segments, which form the mid segment triangle. So if you look at the big triangle, triangle ABC, okay, inside of that you have the red triangle, triangle MNP. That red triangle is called the mid-segment triangle because all three segments, MP, PN, and NM, are mid-segments of the larger triangle. All right, so let's go back and talk about mid-segments again. By definition, the mid-segment is the segment that connects midpoints of two sides. So M is the midpoint of this side, N is the midpoint of this side, and P is the midpoint of this side. So segment MP is a mid-segment because it connects two midpoints. Segment MN is a mid-segment, and segment NP is also a mid-segment. Okay. We're going to learn more about the mid-segment below when we talk about some different theorems. It says here the mid-segment of triangle ABC at the right are, I already read them. Okay, so I don't have to read them again. And then the mid-segment triangle, which I already mentioned as well. All right, so using mid-segments in the coordinate plane. In triangle JKL, so triangle, I think this is, it is J. I didn't see that letter there. So JKL, the big blue triangle. It says, show that mid-segment MN is parallel to JL and that MN is half as long as JL. Okay. So how are we going to show that two segments are parallel? Think about that for a second. What would you need to show in order to prove that two lines or two segments are parallel? You have to show that they have the same slope. So to show MN is parallel to JL, you want to show that the slopes are equal. Oh, that handwriting was very messy. Okay, so I want to find the slope of MN, and then I'm going to find the slope of JL. All right, so for M to M, now you could just count units, right? Rise and run. So you could just do that quickly, or you could get the coordinates of those points and plug into slope formula. I'm just going to count rise and run. First, make sure that you are aware of the units that we're counting by. It looks like 1, 2, 3, 4, 5. So we're just counting by ones on the Y and also ones on the X. That's good. So from N to M, I'm rising 1 unit and running 1, 2, 3, 4 to the left. So the slope is -1/4. For JL, from J to L or vice versa, I'm rising 1, 2 units and running 1, 2, 3, 4, 5, 6, 7, 8 units. So rising 2, running 8. And that's going to simplify down to 1/4. So since they have the same slopes, that means the lines are parallel. So MN is parallel to JL because they have the same slope. All right, so the question again says, show that the mid-segments are parallel. Check, we did that. Next, we want to show that MN is half of JL. Okay, well, what do you think we need to do in order to do that? Distance formula, right? If we can figure out the distance, the length of MN, and then the length of JL, we can compare them. So use distance formula to find MN and JL. Okay, remember without the segment bar, that's talking the distance from M to M and the M to N and the distance from J to L. So for MN, we are going to want to know the coordinates. So the coordinate of N is 0, 2. The coordinate of M, it looks like we have to go over 4 and then up 1, 2, 3. So -4, 3 would be M. All right, so the distance formula is the difference of the x's squared plus the difference of the y squared, all under their square root. So it's -4 minus 0 squared plus 3 minus 2 squared. All right, so that's going to be -4 minus 0 is -4. -4 squared is 16. 3 minus 2 is 1. 1 squared is 1. So I have the square root of 17. Now I have to find the distance of JL. See if I can squeeze it in right next to it. So again, we need the coordinates, which are already listed for us. So difference of the x's, -6 minus 2 squared, it's minus, and then plus difference of the y's, 1 minus -1 squared. Okay, so -6 minus 2, -6 plus -2 is -8, -8 squared is 64. 1 minus -1, that's 1 plus 1, which is 2. 2 squared is 4. So I have the square root of 68. We are going to want to simplify that. All right, that can break into the square root of 4 times the square root of 17. And the square root of 4 is 2, so we have 2 root 17. All right, so is JL twice the length of MN? Well, if MN is root 17 and JL is 2 times root 17, twice root 17, then yes. All right, we just proved that MN is equal to 1/2 of JL, or that JL is equal to 2 times MN. Okay, that's supposed to be an N. Hold on, let me fix that. These two things mean the same thing. It's just depending on how you want to think about it. Okay, so we can use the distance formula to prove that part. All right, let's move on to the next example. So that information leads us into our next theorem. We just showed that the mid-segment was parallel to the side of the triangle, and the mid-segment was half the length of this side of the triangle. So that is not just coincidental. That is according to this theorem. All right, this theorem is called the triangle mid-segment theorem, which says that the segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half the length of the third side. So if DE is the mid-segment, which it is because it connects the midpoint of this side to the midpoint of this side, and I know that they're midpoints because of the tick marks, then DE is the mid-segment. Okay, so DE is a mid-segment. And according to this theorem, the mid-segment DE is parallel to the third side of the triangle, which is AC. And the mid-segment DE is half as long as that third side. Or again, you can think of it as the third side is twice the length of the mid-segment. Okay, understanding both of these can help depending on what the question's asking. All right. Okay, so let's move on. All right, so for the next problem, we're actually not going to do that proof. We're going to skip over that. We're going to move on to example 3, using the triangle mid-segment theorem. My pen. Triangles are used for strength in roof trusses. In the diagram, segment UV, which is right here, and segment VW right here are mid-segments of triangle RST. So what does that mean if UV is a mid-segment? That means that U is the midpoint of this side. So I'm going to put a tick mark here, a tick mark here. And V is the midpoint of this side here. So this segment is congruent to that one. Okay, so keep in mind. It also means that UV is parallel to this third side here. Okay, and that UV is half as long as this third side. Okay, well, if this third side is 90 inches, then what's the length of UV? So let's write those things down. We just said that UV is equal to 1/2 of RT. And RT is given as 90. So half of 90 is 45. So we just figured out that UV, this segment here, is 45 units long. Okay, let me erase some of these markings. So this now I know is 45. Okay. All right. And then we're not done though, because we're asked to find UV, but then we're also asked to find RS. All right. Well, where is RS? RS is this length here. How are we going to figure that out? Notice you're given VW. Okay, so keep in mind we said that V was the midpoint of this side. So this segment here is congruent to this segment here. We know that U is the midpoint of this side. We already had that marked. And W is the mid-segment of this side here. So that means that VW, okay, is going to be a mid-segment of the triangle. It's going to be parallel to this third side. It's also going to be half as long. All right, so let me erase so I have some more room. We can say that RS, that's this segment here, is equal to 2 times VW. And since VW is given as 57, RS is 2 times 57. Therefore, RS is equal to 114. Right? Okay, let's move on to the next example. Actually, we're skipping that one. Go to example 5. Modeling with mathematics. Oops. All right, it says Parrish Street intersects Cherry Street and Peach Street at their midpoints. Let's stop there for a second. Parrish Street intersects Cherry Street and Peach Street at their midpoints. So that means that this segment is congruent to this. This segment is congruent to this. Parrish Street is a mid-segment, so it's parallel to Plum Street. It's also half as long. So Pear Street is equal to 1/2 of Plum Street. Okay, so if Plum Street is 1.4 miles long, then we already can figure out that Peach Street is 0.7 miles long. Okay, all right, let's see if we've already answered all the questions or if there's more to do. Your home is at point P. So here's your house. You live up here. All right. Where am I? You leave your home and jog down Cherry Street. So I'm going to jog down Cherry until I get to Plum. You're going to go over Plum Street to Peach Street. You're going to go up Peach Street to Pear Street. Then you're going to go over Perry to Cherry, and then you're going to go back up Cherry to home. Okay, just lost my space when I was reading. All right, so about how many miles do you run? Well, if this is 1.3, then this piece also down here has to be 1.3. So again, I'm going to go down here, then across. That's 1.4. Okay, they're telling you the entire length of Peach Street is 2.25. So what does that mean for this piece and this piece? We just take the 2.25 and divide by 2 to get 1.125 for each of those. So now that everything is labeled, If you're going to jog down here, it's going to be 1.3 plus 1.3 plus 1.4 plus 1.125 plus 0.7 plus 1.3. Okay, so 1.3 plus 1.3 plus 1.4 plus 1.125 plus 0.7 plus 1.3. Okay. And when I'll add it all together, you're going to get 7.125 miles. Okay, so that's just the use of that mid-segment that we were talking about earlier. All right, let me see what else we're going to do. We're going to jump down to the extra practice. I think there's just one problem. Yeah, we're just going to do one more problem. We're going to do problem number 4. Okay, so the vertices of the triangle are A, B, and C, which are given. What are the vertices of the midpoint of the triangle? Okay, so let me make my coordinate grid just a little bigger and easier to plot points. Okay. So first thing, I got to make an X and Y axis nice and dark right in the middle. Try to draw a straight line in this way as well. Now I'm going to plot my points. A is at -5. I think I have to count by twos probably. 2, 4, 6, right? 1, 2, 3, 4, 5. Yeah, I'm going to have to count by twos. I have to change my scale. So 2, 4, 6, 8, 10. Now, if you have graph paper that's big enough and you don't have to count by twos, I wouldn't recommend it, right? It's usually a little easier not to have to change your scale. But for me, I'm going to have to. All right, -2, -4, -6, -8, -10. All right, the bottom one's -10. -5, 6. So -5, 6 is here. That's point A. 3, 8 is here. That's point B. And 1, -4 is C. So we have A, B, and C. All right, that's not a very straight line, but what are the vertices of the mid-segment? Well, the mid-segment, okay, if I want to find the mid-segment, that means I need to find the point of each side. Now, you can probably easily find the midpoint if you want. You would do rise over run, right? And then just go up half of the rise and half of the run. So what I mean to go from here to there, I'm going up. Remember, I'm counting by 2. So I'm going up 2 units and then I'm going over 1, 3, 5, 8, 9 units. So I'd only go up half of that way and over half of that way to get to the midpoint, right? So I would go up 1 unit and I'd go over, I forget what I said already. I think 4 units. I would go over 4, whatever it is. I forget what I said my over movement was. But the easier way of doing it is to use the midpoint formula, which we've used earlier in this school year. So we're going to find the midpoints of each side. All right, so I'm going to find the midpoint of AB. Okay, so remember the midpoint formula says take your x coordinates and average them. So -5 plus 3 divided by 2, and then take your y coordinates and average them. 6 plus 8 divided by 2. And when you do that, you're left with -5 plus 3. That's going to be -2. -2 divided by 2 is a -1. 6 plus 8. All right, that's going to give you 14. 14 divided by 2 is going to give you a 7. So the coordinate is -1 and then up 7. So that's 2, 4, 6, 7. All right. And then, so that's the midpoint of, the midpoint of AB. Then you're going to find the midpoint of BC, same way. So average of the x's, 3 plus 1 divided by 2. Then you take the y coordinates, 8 and negative 4, and average them. 8 plus negative 4 divided by 2. So 3 plus 1 is 4. 4 divided by 2 is 2. 8 plus negative 4 is 4. 4 divided by 2 is 2. So the midpoint is at 2, 2. And even though my segment was not drawn very straight, it looks like it's about the midpoint. And then finally, the midpoint of AC. So it's A to C, average of the x's, negative 5 plus 1 divided by 2. Average of the y, 6 plus negative 4 divided by 2. All right, so let's do that math. So negative 5 plus 1 is negative 4. Negative 4 divided by 2 is negative 2. And then 6 plus, that's a negative. 6 plus negative 4 is 2. 2 divided by 2 is 1. So we have negative 2, positive 1 as the last midpoint. So those are all the midpoints of the sides of the triangle. And if I was to connect them, I'd have my mid-segment triangle. Okay, so as I said, if you don't have graph paper, you definitely want to use the midpoint formula. If you do have graph paper, another fast way of figuring out where the midpoint is count your rise and your run, and then just do half of the rise and half of the run, and you'll end up at the midpoint as well. Okay. All right, guys, that is it for lesson 6. I'll see you back here for the next one. Bye.